Hello everyone. So on this video, we're going to go over important points in chapter 7, which is about the wage structure. So in this chapter, mainly we're going to talk about why wages differ between different workers. Okay, so we will see that some workers they earn more than others, right? Um, and the reason is, or there are more than one reason, but we can actually group them into basically two. The number one is the productivity differences. So we can have one worker who is more productive than another worker, and that's why is rewarded more than the other worker. Okay, and also in terms of skills, so we can find that the return to skills also differ. Okay, so we're going to talk about the shape of the wage distribution, why wages differ between different workers. So we can basically talk about the age earning profile, which is the relationship between age and earnings. Okay, as the person gets older, earnings increase, yes, but it increases at a decreasing rate. Okay, so there is a positive relationship, but the slope is not constant along each and every age. So there are basically four important properties of this relationship. One is highly educated workers earn more than less educated workers, and it makes sense. A person with a PhD definitely would earn more than a person with a high school degree. Okay, so this is something that we know or we can observe from real life. Number two, earnings rise over time, but at a decreasing rate. So every time you get a promotion, you would have a raise in the salary, but probably at a later age in life, the jumps in salaries are not going to be as high as in early stages of life. Okay, so that's why we say the relationship increases at a decreasing rate. The relationship between these two variables. The age earning profile of different education cohorts diverge over time. Okay, so we're going to be talking about this as well. And then earnings increase faster for more educated workers. So the rate of the increase between one promotion to the next is faster the higher the degrees of education. If we look at age earning profile through different data, and you can check the data at the US Bureau of Labor Statistics, you will find that in general it is taking like a positive relationship that is increasing at a decreasing rate. However, this shape happens at each and every stage of life, stage of education, but the the higher the degree or the higher the years of education, the higher the years of school enrollment, the higher is the curve. Okay, so this graph is for men, but we can also see the same pattern for females. Okay, so yes, a college graduate with starting salary would be higher than a person from a high school dropout who started at 18 years of age, but however this person waited for like 4 more years in order to start the first job, but the starting point here is definitely way lower than a starting point here. And not only that, the rate of increase over time is definitely higher than a person who started from a high school dropout. And we have two intermediate cases in between. So whatever you see for males can also be applied for females, the same patterns that we see or we observe in real life data. Also, besides years of education, workers can update their skills, right? So we have basically two types of on the job training, OJT. So all the OJT is on the job training, like getting workshops, taking some training programs, and the idea here is to increase or augment human capital stock. Okay, so the more years of education, the more skills that are attained the higher the accumulation of human capital. And that's why we basically say it's basically augmentation to the stock of human capital. So we have two types of on the job training. It's either general or specific. The general is for free for everybody working in the firm. So the firm doesn't have to pay anything, and it's basically whatever is acquired can be useful in all firms. Like learning, for example, PowerPoint, learning Excel, learning Word, or any other of these general kinds of training. But there are also specific on the job training that are basically kind of training that is useful for only specific firm. So that's why the firm would be paying for workers to acquire such specific skills, but the firm would also ensure that the worker is not going to leave right after finishing the course or finishing the training, because they want to get the return out of their human capital investment. So the general training is done for everybody. The firm does not have to pay for the cost, so it's just for anybody. Once you get this training, you're good to work in any other company because you augmented your human capital in general, right? But specific ones, the firm has to pay, right, some of the cost of that specific training. But once the firm decides to pay, it has to make sure that it is sharing the return of that specific training. For example, once you finish the training, the firm would tell the worker you have to stay for at least 2 years on the job after you finish this training to ensure that they are getting the return, the benefits out of this augmented human skills. So the acquisition of human capital over life cycle um, looks like this. So every time you augment human capital, we call it efficiency unit, how much you are augmenting, right? Assuming that you can measure this human capital by a unit which is called efficiency unit. It's like when you can measure your utility by utiles. Now we want to measure human capital with efficiency because you're augmenting your efficiency, okay? So assuming that the unit of measurement is called efficiency unit. So every time you're augmenting human capital over your life, you're paying, but also you're getting a rate of return. So again, it's like comparing marginal revenue versus marginal cost. Every time you're learning a new skill, you are augmenting your marginal revenue by an efficiency unit of human capital. Yes, this marginal revenue increases, right? Uh, at a decreasing rate, or in other words, we can say that this additional revenue is going to decline as the worker ages. So the marginal revenue of a person who is 20 years of age, if I can assume that this is just an example, $20 as marginal revenue. The marginal revenue of a person with 30 years of age is going to be little less, let's say 18. I'm just making up any numbers. Okay, so as the person gets older, the marginal utility gets lower, declines. Each age, the worker equates the marginal revenue with the marginal cost. So, for example, the person who is 30 years of age is going to acquire that much of efficiency unit, compared to the person who is 20 years of age is going to get higher efficiency unit. So it's going to invest more in their skills because they are getting more marginal revenue out of this human capital investment. Okay, so when we look at the age earning profile, as we said, it's increasing at a decreasing rate with age. So it's age and earning. The earning is this one, and the age is the time. Okay, so I'm sorry for how the mess of this looks like. I tried to fix it, but it's not fixable. But in any case, our concern is about BT. You can write it as BT or B times T. X here stands for times, minus CT square. So this part is plus and the quadratic part is negative. Okay, so the idea here is as the time increases, or you can think of it as the person gets older, right? Wages, it's log wages, so we read it in percentages. The percentage of wage increases at a decreasing rate. It's a quadratic relationship. A quadratic relationship would look like an inverted U shape, increases at a decreasing rate. So if this is log wage, right? So this is your earnings. And if this is T time, or you can say it's the person's age, okay, whatever. But the most important thing, it's not a straight line, right? It increases, but at a decreasing rate. It's an inverted U shape, all right? It doesn't start from the zero, so this was my mistake. So it doesn't touch this intercept. So let's say I'm just trying to make any age earning profile. So let's say I'm just making it this one. Okay, so this one starts with a certain number, let's say 10K, I'm just saying, and this is a person who is 18 years of age. Okay, so this is the first point. It doesn't touch the intercept, so it's right here. It doesn't touch the y or the x. So a person is 18 years of age. The starting salary, I'm just saying as an example, is 10K. Okay, so this combination is 10, 18. But then as the person gets older, the increments, each additional unit, right? Each additional years of age is gonna lead to, yes, an increase, but the jumps are getting smaller and smaller and smaller, right? Because this one is getting, see, it's getting like flatter towards the end. So that's, if you have taken econometrics class, then this is an inverted U shape. It's gonna look like this, right? It's gonna be a quadratic shape. So T star is the best, right? So the overtaking age. What is the overtaking age? It's the time at which the person is going to say, oh, I'm going to stop here. Okay, so it indicates the time when the worker slows down acquisition of human capital. They're going to slow down the acquisition of human capital. Why? In order to collect the returns of the prior investments. You're done with a master degree, you're going to stop here, you want to acquire the returns of the master degree. So you're going to slow it down, right? And then when you acquire the return of a previous investment, this is what we call overtaking earnings, right? And then when you overtake earnings of those that did not undertake a master degree, for example. So you are overtaking these earnings out from those who did not do, for example, these additional years of education that you did. All right, so the age earning profile, we already did that. So it's an increasing at a decreasing rate. It's a concave or inverted U shape. It slows down over time because the worker accumulates less and less human capital as they get older. So there are kind of prime age where the increments are big, right? But then these increments are smaller and smaller. Just make sure that the jump from each line and the next is 1 year, 1 year, 1 year, 1 year. And that's why in economics, we always use like a marginal analysis, assuming that these are just like a nice lines, right? Each one is just an additional year, 18, 19, 20, 21, 22, 23, 24. So the space here is 1 unit every time, but it doesn't have to be 1 unit here, right? So here is just the increase in wage, which is like, it's the biggest at early ages, gets smaller, smaller, smaller as this line gets flatter and flatter. So the jumps decreases. But the most important thing is, in marginal analysis, we always say for each additional unit. So this one has to be one additional, one additional, one additional, right? And here we're going to observe what's going on with these additions, right, on the y axis or the vertical axis. So, policy applications, when you try to evaluate training programs, um, so on the job training, there have been like there have been like policy applications trying to collect data, trying to figure out is whether these training programs are worthy or it's not, like we don't have to invest that much in it because it doesn't um, lead to much of uh, human capital augmentation. So these training programs, right, basically targeting or trying to target those who are disadvantaged workers or low income workers. They're trying to target those kind of workers in order to offer them training programs and increase their human capital skills. Okay, so one of the important training programs is the 4 billion of federal spending per year, trying to increase, right, human capital per workers. Many studies have been trying to analyze the return of these human capital investments. Like, is it worthy that we pay 4 billion of federal spending per year on these disadvantaged low income workers, or it's not worth it? Okay, so these studies have been trying to get an answer, and many of these conclusions out of these studies were actually unclear because of what we call a self-selection bias. Again, if you have taken econometrics, then you will be able to understand what is a self-selection bias. But if not, then this paragraph would explain it to you. All right. So when these programs open, many of the workers who sign up for these training programs are signing up because they are interested in the training program. They are very well motivated. They have already high skills and they are very ambitious about the program and they are happy about it and they want to engage more in it. So there are some kind of unobserved human characteristics embedded in workers that we cannot see, but it's going to affect the outcome of the results. So after the program, and when we try to analyze the results of the program, and we cannot actually say that these programs led to high return on human capital investments because we don't have the situation what if we did not offer these same kind of workers who engaged in the program, what if we didn't offer them the program, right? So of course there are some econometric ways in order to try to um, um, kind of isolate the effect of what if those same workers, right, have not been offered the program, and how can we evaluate their human capital investment with and without the program. Um, like, for example, randomized controlled experiments. These are one of the kinds of methodologies used in order to do so. But in general, for the scope of your course, just it is unclear whether these programs are worthy because of the investment of 4 billion or whether it's because embedded characteristics in the workers who engage in these programs. All right. Um, Social experiments. So the national supported worker demonstration, they actually found that 10% of the return to investment in human capital is for workers treated under the program. So this is one of the programs that found an answer by saying yes, these training programs increases human capital return. All right, let me stop here and we'll continue in the next video.